first question I will ask to Mehdi. We talk about weird words like carbon footprint, carbon emission. Do we need to be expert on these fields and to learn all these metrics? Mehdi.
I will explain you. We don't need to be expert. And I will begin to define what is carbon footprint. Carbon footprint is all the greenhouse gas emission by human activity. And it's expressed as a dioxide carbon equivalent. Why dioxide carbon equivalent? Because it's the most produced greenhouse gas by human activity. For about 74% of greenhouse gases produced by human activity. And the operating theater is a small area in the hospital, and it has a big consumption of energy and producing waste. In this McNeil study, when they studied 3 operating suites in 3 different countries, Canada, USA, and United Kingdom. And we see that in 3 hospitals, it's not the healthcare system, but only 3 hospitals, they produced 3 million, 4 million, and 5 million equivalent, dioxide carbon equivalent every year. And if we refer this carbon equivalent or CO2 equivalent per unit area basis, we have what about 2,000 kilogram CO2 equivalent per meter square. And if we refer these numbers to cases or patients, we have a huge difference between 2 neighbor healthcare systems, the Canadian and the American. And in details, when energy accounts for most of the emissions in the British hospital, the anesthetic gases prevail in the American and the Canadian one. Why? Because they use a gas that have a huge greenhouse gas equivalent. It's desfluran. And the principal strategies or pillar to reduce emissions of greenhouse gases. Here in this schema by Kagoma, we have the 5 pillars that are reducing, reusing, recycle, and the 2 last pillars are rethink and research. We will start with reducing. We can reduce our waste by good segregation, by reusable material, and reduce energy expenditure. We can also have a just-in-time model to reduce overage, and I will only focus on 3 pillars that are reducing recycling and reducing the overage and reducing energy expenditure. So, in hospital, waste must be segregated in hazardous waste and normal or municipal solid waste. And if we see that World Health Organization have emphasized in 2009 to have sustainability use of healthcare systems, and they say that we cannot go over than 15% of hazardous waste. And if we focus on the treatment, the disposal of hazardous waste is 3 times more productive of CO2 equivalent than normal one, and it costs 6 times more than normal waste. And for energy expenditure, in my operating room, we have tried to do something because operating room is a high consumer of energy because for safety patients, we need rules of ventilation, of temperature, of lighting, and this operating room remains unoccupied up to 40% of time. So to save energy in my hospital, we have shut down the ventilation and the lighting in the non-used operating room. And that permits once to save energy because we had a consumption, what about 1,500 kilowatt hour per meter square, and we could reduce it by half. And this permit to save cost for about 48%, because cost of energy, we had a cost about 7,000 euros per operating room to about 3,700 euros per operating room. And it shows that it's available also in winter and in spring, and it's really significant. And the last thing we did in our operating room is to reduce overage. What is overage? Overage is all the material reading, and finally we don't use it. And we have estimated our overage in my hospital for about 11% for minor surgery and about 4.6% for a major surgery. And it's majority for materials, what about 60%? And
so we've lost the slides.
We have lost the slides, please. The last one. 60% for material and 40% for pharmacy. So if I go back to this strategy, we have 5 pillars, and the 2 last ones is to rethink how can we use anesthetic gas. Henrik will explain us how to do, and to promote research about this sustainability in the operating room. Thank you.
Thank you very much, Mehdi. This is impressive, what you did in your hospital. So you measure a lot of things. Do you think that we need to be specialized and to be expert to measure, to get the metrics, to do what you did in your hospital?
No, we don't need to be expert. Me too, I'm not an expert in footprint, but we have just to start to, as Jan said in a few minutes, to have a team, a team in our hospitals with nurses, doctors, surgeons, anesthetists, and we need technical team in our works. So we need engineers that can help us to evaluate our consumption and improve our sustainability.
Okay, I have seen that you give carbon emission equivalent as a result, but you also give financial benefits.
Yeah.
It's like, and each time we see this, we see that we have a decrease in environmental impact and also a decrease in cost.
Yeah, it's a parallel, and our administratives needs to have an evaluation of money, because we can explain them that it's for the planet, but they have to know the costs, and we have to improve the sustainability and prove that it saves money.
Okay.
It saves money, it saves planet, and it saves money.
So if you want to begin, that's the first thing you need to do to your administrative department.
Yeah.
Okay, I will help you to save money, and then you have the final result that you want. It's to improve the environmental impact. Okay, let's talk about the strategies you explain. I've seen that we have the slide. If we can just have the slide, this slide. We have reduce, reuse, recycle, rethink, research. It seems that one or two words are missing. The first one is refuse. We talked with Jan about single-use devices. We need to refuse them when we are explaining what we want to do.
From 80s, we have changed our consumption in the hospital, because the bloodstream diseases are widespread, and we have this single use, and the industry says that it's for the patient safety. So we have other solutions. We have recycling, and we also have reprocessing. And in North America, Canadians have more than 28% of single-use devices that are reprocessed. What is reprocessing? Reprocessing is to make single-use devices suitable for reuse. The laws in Europe are a little bit late, because there is an European the European decides to reprocess the medical devices, but there is only Germany that makes reprocessing and use it in their medical healthcare.
So you mean that we cannot buy German products that they are reprocessed to use them in France, for example, or in Sweden, or anywhere?
No, it's only available in Germany, and we cannot buy reprocessed products in Germany and use them in France. But the principle is to reprocess the products or the single-use products that we use in France. So the other solution is to send all our single-use by recycling them and reprocess them in other countries.
In order to replace the single-use devices, we can compare single-use versus multiple-use devices. However, if we take, for example, the example of fibroscope, single-use fibroscope that are proposed to us, for example, to replace the usual fibroscopes, there is a cost, an ecological cost of decontamination. Can you explain if this cost is very important?
This cost is very important because recycling and reprocessing consumes a lot of energy.
Okay.
And it depends on the energy of the country. We have a study, we have an Australian study that compares the single-use versus the reusable devices in anesthesia. And in the Australian healthcare system, there is no benefit for CO2 emissions, because their energy process is based on coal, and it's not benefit.
Okay. What you mean is that, in fact, it's very difficult to have the entire cycle. I mean, we should focus on the life cycle of the device.
Yes.
Explain us what is a life cycle.
We must focus on the life cycle of the device, because saying that we have to recycle it and reprocess it,
it's not enough.
It's a fact, but we have to see beyond the recycling to see how much energy it will consume, and what is the cycle of the product from reprocessing to reuse, and how much times can we reuse it.
And also transportation,
yes,
if you
we
buy
have
something from the other side of the planet, and
yes.
etc., etc. So the first thing you should do is to look at the device paper to see where it comes from.
And where, what can we do with it once it's used by us.
Okay, so thank you. So you see that there is a lot of things to finally to understand, to learn. Let's go to the different sites. For example, the site of the French Society of Anesthesiology and Intensive Care, and look at the green SPHAR page.